Okay, so should we start? Okay. So let me first discuss about your quiz. Okay. So we will, because some students say that they will be absent today, because we planned to have the quiz today, right? But Monday I was quite unaware that Monday was a holiday due to the, what is that? Sports day, yeah. So we plan to have the quiz next Thursday, okay? Next Thursday, okay? And the quiz will be multiple choice question. Multiple choice question. That means each question have 4 answers. You have to pick the right answer. Okay. There will be 5 questions. Okay. 5 questions you have to choose the right answer. Okay. And it is an open book. Open book. Okay. Open book. That means you can refer to your notes, books, but no internet. Okay. So you have to write the answer here, then we will exchange your answer sheet among your friends and you can check with what is the right, what is wrong. Are you getting me? Okay? So you will get how much you get, how much score you got right away. Did you get my point?
So the answer will be provided at the
yeah, right after I will show you the answers, whether it is A, B or C or D, right? And you can check that whether you did it right or wrong. Okay? Is that okay? Yeah. So next Thursday, Monday we'll have the regular class, but next Thursday we will have the quiz.
So
here.
the quiz, what is the range of the
Up to what we discussed to the previous class.
Okay, so linear OD.
Yeah, linear OD up to the chapter 1. Whatever we studied.
Okay.
First order linear OD, separable OD, whatever the things, okay? Whatever things. I cannot say because I am saying open book. Then if I will say that, I will ask this question, what is the point? Okay, yeah. So you can refer to you, whatever notes you have or whatever books you have, you can refer to them. Okay? But no computer, no mobile phones, no internet. Is that okay? Yeah. Good?
And how about the calculation?
Yeah, you can use calculator. Yeah, no problem. But no phone, no internet, and nothing. Whatever hard things you can bring. You can bring your book. Okay? You can have your notes. Whatever you have. But no internet. No phone. Okay? So you have to do it right here. You have to pick the right answer. You can do the calculation. And each question will be both English and Chinese. So that those who have difficulties in reading or understanding English, they can read it in Mandarin. But the problem is that I don't know Mandarin. I just use ChatGPT to translate, okay? But I don't know whether ChatGPT will translate it correctly or wrongly, okay? So I believe that we can trust ChatGPT. It will not make anything wrong. If it will provide anything wrong, then I'm not going to be responsible for that. Okay? Okay, is that clear? Okay, pass the message to your friends. Okay, if you are absent, it will be absent. If you are present and appear the test, it will be present. Okay? Okay. So now let's. So have you recorded whatever I say?
Yes, okay.
Okay, so those who can watch the video, they can also get this message clearly. Okay, so let's start something new for today onwards. It's about the second chapter. Okay, so second chapter means we are going to discuss about the second order linear ODE. Okay, so we are going to discuss So if I will try to show you what exactly the second order ODE, second order linear ODE. In general, I can show you that this is actually the second order ODE should have x, y, y dash and y double dash is equal to 0. This is the function it should be, right? So you know what is x, what is y dash, what is y double dash. So that means when we try to solve, we need to find out, our objective should be finding this one, this unknown function. Because this one is the variable. And this is the first derivative and second derivative. Okay? This is the first derivative, this is the second derivative. And this is the unknown function, which we need to find out. That means when you try to solve a second order linear ODE, we need to, our objective is to find out this y. It's always, our objective is to find out the unknown function, that is y. Great. So we discussed about the first order linear ODE. Okay. Now what happened in the second order linear ODE? So we can say the second. So this one is the second order ODE specifically. And if I will specify that what is the second order linear ODE? So this is, I can say y dash plus px y dash, y double dash plus px y dash plus qx is equal to rx. If the ODE is in this form, then I can say that this is, if the ODE is in this form, and I can say this ODE is a linear ODE. So I can say this ODE is a linear ODE. Now the point is that we also see the first order linear ODE, quite similar, but there was no y double dash. Almost rest of the things are quite similar, right? Oh, this here it should be qxy. Okay, I missed the y. So then we can also say that we can have the second order ODE could be a homogeneous and non-homogeneous. That means in this ODE, if this Rx is equal to 0, then we can say it is homogeneous, and if Rx is not is equal to 0, then it is non-homogeneous. It's pretty much same concept. That means, for example, if I will ask you, I'll write two ODE. One is, let's say, xy double dash plus y dash plus xy is equal to 0. Another one I will write y double dash plus 25y is equal to e to the power minus x cos x, something like that. So which one is homogeneous, which one is non-homogeneous? Both are second order. So this one is homogeneous and this one is non-homogeneous. Right? Then the next thing is, there is some concept in homogeneous linear ODE. Our focus is now homogeneous ODE. Okay. So we will discuss how to address this homogeneous linear ODE, and after we finish the homogeneous part, maybe we have different types of homogeneous linear ODE. Later on we will move to the non-homogeneous, which also we are going to discuss, specifically the non-homogeneous in detail. And then we will go for higher order ODE. This is first year we finish. Then we are going to discuss the second order. After we finish the second order, homogeneous, non-homogeneous, we will study higher order ODE. That is third order, fourth order, like so. Okay. So there is a concept called superposition principle. Specifically I can mention, it is the homogeneous linear ODEs there is something called the superposition of solution. What exactly this concept? Let me explain you. Actually, basically we named, technically it was named as superposition principle of homogeneous ODE, homogeneous linear ODE. Okay. Technically it was proposed as superposition principle. Okay. So let's understand this one with one simple example, then we can go in detail theoretical context. Suppose I will write a ODE, let's say y double dash plus y dash plus y is equal to 0. This is my ODE. Okay. This is the problem. This is the second order ODE. Of course, it is a linear ODE, linear homogeneous ODE. Okay. So, can you tell me what is the solution to this ODE? What is the solution of this ODE? Solution means what? The y. What is the y of this ODE? Say it again, minus y double dash no, you are not guessing it. No, I mean, you are not getting it properly. I'm saying, suppose I will ask you, can you tell me what is the y? This is the OD. So, what is the y value that satisfies this OD condition? Do you have any idea? What exactly this is? This one is nothing but y double dash is nothing but y, sorry, minus y. So what is the value of y, or you can say that y is nothing but minus y double dash, whatever, maybe. So what is the value of y that satisfies the double derivative of y, negative of double derivative of y? Sin y. Now sin what? I mean y is equal to, one is I can say y is equal to, if I take sin x, if I take y is equal to sin x, right, if I take y is equal to sin x, then what is y dash? Cosine x. What is y double dash? Negative sin x, that is minus y, right? Similarly, is there any other solution? Is there any other solution? What about if I will take y is equal to cosine x? Is it satisfying? Yes, because if I take y dash, it is minus sin x. If I take y double dash is equal to minus cosine x, that is minus y. Now in this case, y is a solution, y is equal to sin x is one solution, y is equal to cosine x is also another solution. Then which solution we should pick? Yes? Say it again.
Depending on the situation, you want y to satisfy other conditions
Satisfy other condition.
that you make to write something like x equals to 0 to satisfy one condition. Different other things that you want to use, like you want y to be cosine of phi. So depending on what you choose.
No, you are not getting my point. I'm just saying that you can choose whatever value. Okay. If you have some value, you can choose. My point is that suppose I choose one. Do you have any other value, that x or y, whatever you are saying? Do you have any value? Because there are multiple ways to find out the solution. Okay, one is that, what is that? You guess some solution and predict that, yeah, this is my solution, and you try to substitute that value to test that, yes, whether this one is satisfying the result or not. Satisfying whether this particular result I am guessing is satisfying to this case or not. There are multiple ways. That means there are certain problems you cannot solve directly. In that case, you guess, yeah, this might be the solution, and you apply it. Sometimes it works. Okay. My point is that here I have two solutions. One is the sin x is satisfying this case as well as cosine x also satisfying the solution. Okay. Right. So which solution should I take? Any confusion? No, it is showing me that this is one solution, this is another solution. And what if I will take the solution y is equal to sin x plus cosine x? If I take the solution sin x and cosine x, then we try. Then y dash is what? Cosine x, and cosine x is minus sin x. Yes. Then what is y double dash? Minus sin x minus cosine x. That means it is minus sin x plus cosine x minus y. It is also satisfied. So here comes the concept here. Here comes the concept for I mentioned something called superposition principle. Okay. Here comes the basic idea or the theorem. For a homogeneous linear ODE, let's say y double dash plus px y dash plus qx y is equal to 0. So I'm saying homogeneous, that's why it's 0. That means Rx is equal to 0. Okay. Any combination of two solutions on an open interval I is a solution of the ODE. Understand the statement. That's why I give you the example first. If there are two solutions, because we are talking about second order ODE. If there are two solutions, then combination of two solutions, adding two solutions, also become the solution of the ODE. Right. Now one thing is missing here is that I have not added the constants. Now if I go back to the same problem again, that I found, I wrote the ODE was y is equal to the solution was y is equal to sin x plus cosine x. We tested this one and it works. Suppose I put some random constant. Let's say I write that y is equal to, let's say, 4.7 sin x minus 2 cosine x. Is it going to affect the result? Is it going to satisfy? Of course it is going to satisfy. Because if I will further take y dash, if I take y dash, then it is, let's say, 4.7 sin x minus 2 cosine x. Cosine x minus 2 sin x, it should be plus 2 sin x, right? And if I take y double dash, it is minus 4.7 sin x plus 2 cosine x. This is the y test. That means if I take the minus, it will be the same. Minus 4.7 sin x minus 2 cosine x, which is minus y. Right. That means even if I put this value, it's also going to give me the same answer. So what is the point here? Despite having two different solutions, and particularly I can write here, in particular, for such an equation, sum and constant multiples of solutions are again the solutions. That means when we have multiple solutions, we try to add by putting any constants, also giving you the same solutions. This is the basic concept. Right. Now this is the theorem I put. Let's prove this theorem. That means in general, if I will try to prove this theorem, let's say we have a ODE, let's say, here is the proof. Let's say the ODE is y double dash plus p y dash plus q y is equal to 0. This is the given ODE. This is the ODE. And for this ODE, we have given two solutions. Let's say y1 and y2. We have two solutions. One solution is y1 and another solution is y2. Let's assume. Now if y1 is a solution of this ODE, if y1 is a solution, if y1 is a solution, then can I write y1 double dash plus p y1 dash plus q y1 is equal to 0? Can I write? If y1 is a solution, then I can definitely write this. Similarly, if y2 is a solution, then I can also write y2 double dash plus p y2 dash plus q y2 is equal to 0. So two things I have mentioned here. One is, if y1 is a solution, then this will satisfy the ODE. If y2 is a solution, it is also going to satisfy the ODE. Okay. Now since we have two solutions, what I am saying that I can have a solution y is equal to y1 plus y2. That is what the theorem is saying. Okay? With I can put any constant here. Let's say I put some constant here. C1, C2. Right? Then I can say y, if y1 and y2 are two solutions, then I can say by the concept, the definition of the theorem, by multiplying two constants to those solutions, adding of them can also be my solution. Yes or no? That means I can say y is C1 y1 plus C2 y2. This is the solution. Now let's put this solution and test in the ODE. What is my ODE? My ODE is this one. My given ODE is y double dash plus p y dash plus q y is equal to 0. This is the given ODE. And what is my solution? My solution is C1 y1 plus C2 y2. So let's put C1 y1 plus C2 y2 double dash plus P C1 y1 plus C2 y2 single dash plus Q C1 y1 plus C2 y2. Is there anything wrong? That means if y is equal to C1 y1 plus C2 y2, what I did, I just put, in place of y, I just put C1 y1 plus C2 y2. That is what I just did, nothing else. Right? If I put that and you try to calculate. I can easily try to find out this. If I take the derivative, it is C1 y1 double dash plus C2 y2 double dash plus P C1 y1 dash plus P C2 y2 dash plus Q C1 y1 plus Q C2 y2 is equal to 0. What I can do that, let's put all the C1 together or all the y1 together and all the y2 together. That means if I can rewrite this one, it's C1 y1 dash y1 double dash plus P C1 y1 dash plus Q C1 y1 dash. So this is my first part plus C2 y2 double dash plus C2 plus P C2 y2 dash plus Q C2 y2 is equal to 0. So this is my second part. That means I am getting C1 y1 dash y1 double dash plus P y1 dash plus Q y1 dash plus C2 y2 double dash plus P y2 dash plus Q y2 . Yes?
That Q1
Mm-hmm.
is that Y1 do not have one Q.
Y1. Oh, this one. Okay, yeah. Okay? Now you can tell me what is this value? And what is this value? Because if y1 is a solution, we know if y1 is a solution, this value is 0. If y2 is a solution, this value is 0. So ultimately we are getting C1 into 0 plus C2 into 0 is equal to 0. Right? Likewise, in the first order ODE, second order ODE also you will have initial value problem. So let me tell you that concept since we have little bit time left, and we will discuss about the how to solve the second order linear ODE. We will discuss in the next class. Okay. So let me tell you about the initial value problem concept in second order ODE. Because initial value problem in second order bodies. The first thing is that we came now. The second order ODE, especially I am talking about homogeneous ODE, okay? So let mention that one clearly. I am not talking about non-homogeneous. Second order homogeneous ODE, homogeneous linear ODE, homogeneous linear ODE. The second order homogeneous linear ODE is initial value problem consists of two initial conditions. Two initial conditions. Because in first order it was just one condition, y x something, it was given. Here the condition is y, let's say x0 is equal to, let's say, some value k0, and another one is y dash, let's say x0 is equal to some value k1, something like this. And these values, these two conditions, these two values, these initial values used to determine what? Yeah. This value is used for, what is the purpose? Why we use initial values? Yeah, particular solution. So what exactly we need to determine here? Constants. But which constant? C1 and C2. Because there are two constants. Because there are two solutions. C1 y1 plus C2 y2. So that is why it was given two constants, two initial conditions to find out two constants, so that after finding the two constants, we can have the particular solution. We can have a general solution, that is C1 y1 plus C2 y2. But for particular solution, we have to solve to find out both the value of C1 and C2. Then we can say that this is the particular solution. To determine C1 and C2 in y is equal to C1 y1 plus C2 y2, if this is the solution. Just like if I will give a very simple example in 2 lines, the problem we solved, like y double dash plus y is equal to 0, and we find out the solution, y is equal to c1 cosine x plus c2 sin x, something like that. Okay. So here I can give one condition is that let's say y0 is equal to 3 and y dash 0 is equal to 0.5 or maybe 0.5, something like that. Then how to solve this one? You need to calculate what is y dash. You have to put the value for the y, this value, to find out what is the y, and then the value. That means you can put y, what is the y dash? Your y dash is minus c1 sin x plus c2 cosine x. So what you need to do? You need to put this one here and this one here. When you put these values, it will help you to find out what is the C value, what is the C1 and what is the C2. And finally putting those values, you can have your final particular solution. Right? Okay, so thank you very much. See you in the next class.